Assalamualaikum and hi, my name is BINTI HARUN. Welcome to Electricity and Magnetism. Before we go further, let me highlight 4 main topics we will learn today. First is vector analysis, electrostatic field, magnetostatic field, transformer and motional EMF. So let's start. Let's go into vector analysis. Basically, in this chapter, we will learn about the basic vector. This includes addition and subtraction vector, dot product and cross product, conversion coordinate system, integrating DL, DS, DV, and the del operator. For the conversion coordinate system, you must know about those 4 quadrants because you may use it in the conversion subtopic. This chapter is not too complicated since many formulas are already given in the appendix during the examination. First and foremost, you should know that vectors have both magnitude and direction. So when you want to write it in vector form, you must use vector notation with an arrow on top or represent it in bold letters. The famous equation asks you to draw the position vector, so you must know the axis x, y, and z. To draw it, first you marking for the x and y coordinate, then to the z coordinate, and lastly, pull an arrow from the origin to the last mark to show the direction vector. These are the addition and subtraction vector with the example question. Next, the dot product is a simple solution where you multiply vectors a and b for each component and add them together to get a scalar quantity. For cross product, to solve it is by using a 2x3 matrix and finally get the answer in vector quantity. Addition information, the triple product vector, when the dot product and cross product comes together, you must to solve the cross product first. The conversion are divided into 3 coordinate systems, which are Cartesian, cylindrical, and spherical. Cartesian is the simple coordinate including x, y, and z, where all values can be from negative infinity to positive infinity. This is the first formula you need to memorize, which is distance between 2 points, and Cartesian is the most formula you will use. Next, we go into integrating, where it is divided into 3 systems, which are Cartesian, cylindrical, and spherical. For this is the second formula you need to memorize in this chapter. The length you need to integrate 1 time, area integrating 2 times, and volume you need to integrate 3 times. You need to remember all this formula because you may use for the next chapter. Next is del operator, which are including divergent, gradient, Laplacian, and curl. All these formula you don't need to remember because they're already given in the appendix. What you have to do is you just need to know when and how to use it, where it's including differentiation. Now on the next topic, which is electrostatic field. In this topic, the aim is to find the electric field E by Coulomb's law, Gauss's law, and electric potential. In the Gauss's law and electric potential, you will find 2 Maxwell equations. And lastly, we also learn about the current density. The formula for electric field E is force divided by charge. The force can be found by its formula. These are the charge distribution formula. The charge not only as point charge, but the charge can be distributed in line, surface, and volume. So all these have their own formula. The first Maxwell equation has involved the del operator, which is divergence of a vector D. The most frequently equation you will use, which is electric flux density D, because from this equation you can get the electric field. Next is potential difference, where in this part also you can get the work done. The aim is to find the electric field E, right? So that is the relationship between E and V. From the derivation of all the formula, you can get the second Maxwell equation. Lastly, in this electrostatic field topic is the current density denoted by J. So these are all the formulas that you will use in this part. The second last topic, which is magnetostatic field. The aim in this topic is to find the magnetic field H by Biot-Savart's law, Ampere's law, and magnetic flux density. Same goes as electrostatic field before this. Biot-Savart's law is same as Coulomb's law. Ampere's law same as Gauss's law. In this chapter, Ampere's law and magnetic flux density, you can get the two more Maxwell equation. Divided into two, the current carrying in straight and circular loop. Third Maxwell equation is include the del operator, which is curl of a vector H. And the fourth Maxwell equation is the divergence of a vector B. We now on the last topic, which is transformer and motional EMF. This part is including Faraday's law, where it will divided into three: transformer EMF, which is the stationary conducting loop in a time-varying magnetic field. Second is motional EMF, where it is the moving conducting loop in a static magnetic field. And lastly, including both transformer EMF and motional EMF, where the moving conducting loop in a time-varying magnetic field. And all these have their own formula you need to remember. So basically, in electricity and magnetism subject, we will learn all the four Maxwell equations. So that's all from me. Thank you for listening. Bye.